Hey guys, Marcelo here. Good morning, good afternoon, or good evening, depending on the time zone that you're watching this session. And welcome to another session of Data Platforms Virtual Summit 2022. In this session, we're going to talk about how to use Apache Kafka to replicate data from a Postgres instance into a SQL Server instance. All right, quick question for the DBAs that are here. You probably came across the following situation. You need to replicate data, or you need to transfer data, you need to migrate a database, anything of the sort, and the data sources, the endpoints, are different. For example, I have a MySQL instance and I need to bring that data into a SQL Server instance. I have a SQL Server instance and I need to push that data into an Oracle database. I have, for example, Postgres database, and I need to push that data into an Oracle instance. You get the idea. If you're a DBA, if you have any number of years worth of experience as a database administrator, you probably ran into this requirement. Let's say it's not an issue, it's simply a requirement. And well, we need to figure out how to move that data around heterogeneous data sources. Nowadays we can leverage some pretty darn good tools, or pretty darn good options. We have pretty darn good options for shuffling and syncing that data around. Let's take a look into one in this session. Real quick, introducing myself. Like I said, my name is Marcelo and I work as a Microsoft Data Platform internal principal consultant at Pythian, database company based in Ottawa. We also have offices in Hyderabad, India, United States, Europe, and we pretty much work across the globe. And yes, we do have openings. So if you're interested in working from home and you enjoy database problems, Microsoft SQL Server, Oracle, Postgres, MySQL, big data, pretty much anything data related, make sure you check out our careers page, which is listed down here at pythian.com/careers. You can also connect any of my social networks. The link is right over there in that Linktree URL. So let's get this started. What about our PPT, our demos and scripts? Pretty much everything is already baked in, and in that link that you're seeing, if you point your mobile device into that QR code, you're going to be able to download everything. And it's going to also be packed in the official DPS Summit websites as well. But it's over there. So let me start that by showing you the functionality that I'm looking for right here. Okay, so I have the scenario running in my environment here, in my virtual environment here. I have a Red Hat VM here, and that Red Hat VM is running a Postgres instance, and it's also running a Apache Kafka binaries as well. It's not exactly Apache Kafka purely. It's a Confluent platform client, which bakes in Apache Kafka and makes our lives a lot easier when we're pretty much administering that. I'll talk about it later, but I just want to show you the functionality, or exactly what we're looking at right now. So I have a data source here, which is Postgres, pretty much. Okay, it's a table, pretty vanilla, pretty straightforward, pretty simple. Table called person. Any system has a table called person, any whatsoever. Okay, I have 8 lines here, 8 rows here, pretty straightforward, very simple. And if I go to my SQL Server, my SQL Server is here, and the replication is on, the virtual machine is on, everything is working as expected. I have a database here, And guess what? I also have this table called person, okay? And if I hit select star from person, what am I going to get? Guess what? Yes, I'm going to get those same exact 8 rows. I have some extra columns here that I add normally for debugging functionalities, but we can remove those later. Anyways, okay, Marcelo, that's good, that's fine. What happens if, for example, you're showing me static stuff? What happens if, for example, I want to increase the number of rows here? Say, I want to insert into person, okay? First name, oh damn it, there's no IntelliSense in PG admin. Last name, email, but it's a pretty simple data set, so that's fine. Values. Then I'm going to add, for example, 9th. That's fine. I'm going to add the end, for example. As an email, I'm going to add here nte@gmail.com, right? Great, perfect, awesome. Then let's execute that. Right, if we select from that very same table, you're going to see that I have another row here. And so a new row was added, right? Pretty straightforward, okay? For the database persons here, for the database people here, pretty straightforward, pretty walk in the park. And if I select star in my SQL Server side, you're going to see, funny, it's here as well. Okay, Marcelo, I understood. I want to see if you are able to, for example, update these guys' email, okay? Update person, set email, where let's add where in ID 11. That's part of the 11th commandment. You shall know thy data. Okay, so you know your data pretty well. So set email to, for example, testing@acme.com. Okay, so update, select star to see that again. You're going to see that there's a testing at Acme here, so it successfully updated it. Awesome. What if we select star from person here? You're going to see that it changed as well here. Interesting, interesting. What's doing all the magic here? And let's see another example. For instance, let's delete that row, okay? Delete from person, where ID equals 11, right? Pretty straightforward as well. So you see the line is gone here. And if you select star here, you're going to see that the line is gone as well on the SQL Server side. Very, very interesting. Okay, now what's going on here, Marcelo? Let me go back to the PowerPoint so I can show you guys what I'm doing. So the scenario that I just showed you is I have a data source, which is a Postgres instance, and it has some data. For the sake of simplicity, it has only one table with some data there, okay? Very simple, very vanilla. And I need this data to be replicated, to be added into a SQL Server instance. Database table as well. Data is coming from Postgres and it's going to SQL Server. That's what I need. Let's get back a little and talk about native replication, or what we have native to SQL Server to achieve this. When we think about SQL Server and we want to replicate data between several instances, for example, I have this overall architecture, this generic architecture. I have a publisher and I have a subscriber. I also have a distributor, which can be in the same instance as the publisher and in the same instance as the subscriber. Now, I'm not going to discuss best practices here. for now, okay? And we also have articles. Articles are pretty much the objects that are being replicated between the publisher and the subscriber, okay? Very straightforward, very vanilla. If something changes on the publisher side, something needs it also needs to be replicated to the subscriber side. So moving on, we have, in this scenario, we have only SQL Server, okay? In this scenario, we have heterogeneous replication, which means that I have SQL Server as a producer, but I don't have SQL Server as a subscriber anymore. Interesting. Back in the day, when we used to have, I think SQL Server 2016, up to SQL Server 2016, it was still supported, but it's marked as deprecated. Heterogeneous replication natively in SQL Server is marked as deprecated as of SQL Server 2019 and 2022, of course. And it also only used to work with Oracle. So you could have a transaction that was starting on in the Oracle side, and you would read that transaction in the SQL Server side, and vice versa would work as well. So you would have a transaction that would start on the SQL Server side, and you would have any of those tables or articles that were being generated on the SQL Server side being replicated into the Oracle side as well. But that scenario is not supported anymore by Microsoft, okay? But that's a scenario where heterogeneous replication comes into place. I have a SQL Server publisher, and I have, for example, an Oracle subscriber, or I have an Oracle publisher and a SQL Server subscriber. That's how it used to work, or that's how it used to be supported. But again, going back to the scenario where I showed you guys at the beginning of this demo, we don't have support whatsoever from Postgres into SQL Server. There's no support for that whatsoever, or there's no native support for that from the Microsoft perspective, and nor from the Postgres organization perspective. The problem that we have here in this scenario is this. There's no official support for that, okay? And back in the day when it was supported, only Oracle was available, only Oracle database was available. And there's also no heterogeneous replication from the Postgres side as well. And we could leverage any third-party tool, but that would be kinda sorta expensive. Yes, there are many third-party applications there that would do that, but they're expensive. So we had come up with a not so expensive solution, if you understand what I mean. When the customer says, I don't want anything expensive. Okay, you know what I mean. Okay, so possible solutions for that scenario. We could use a third-party tool like Click Replicate, which is awesome, by the way. It's very good, but it costs a lot of money. Anyway, it costs. There's no way around it. They're a company, they're enterprise. They cost money. That's it. And also another good example is Cloud Basics. They're very good at migrating data from RDS or from SQL Azure, the PaaS offering, into any other vendor or any other option that you might want. You can also manually create and develop your ETLs into Azure Data Factory. That is a very lengthy and error-prone solution, meaning you're going to need to administer it, you're going to need to troubleshoot it, and you're going to need to develop it. It might take a while, and you might also need a development stage. You might need a lower environment to achieve that as well. So you need to test and fine-tune everything that you're pretty much doing. And you're going to need to create pipelines for each and every single table. Anyway, we're going to need to do that anyways, but it's kind of a lengthy process. And you can also use a great tool called Apache Kafka, which was created by a necessity that LinkedIn had back in 2011. It's not a replication solution per se. It wasn't born as a replication solution. Apache Kafka was born as a streaming solution, and it is still a streaming solution. It's not a replicate solution, but it works very well for replication between two different data sets, two different and completely different data sources, data source and data destination, etc. Back in 2011, the engineering team at LinkedIn had to come up with an idea or some sort of product or some sort of solution as to how to show the candidates, well, not candidates, the members, the social network members, any posts that was based on their interests and also on their connections. Connection is who they're pretty much well connected with. And bear in mind, this is not today. This is 2011, like 11 years ago. This has some time already. They had to come up with a solution, and then after they came up with a solution and they used that, they open sourced the solution, which is now called Apache Kafka. After that was pretty much complete. After they were successful on open sourcing that, the team that created the product, the solution, founded their own company called Confluent.io, which pretty much serves or offers Apache Kafka as a service, which is pretty awesome, by the way. If you think about it, you simply, with a few clicks, and I'm not getting any commissions out of them here, okay, guys. So with with very few clicks in your cloud provider of preference, you can create connectors between your source and your destination data, and then you can put it to good use. For example, put it for streaming data, for streaming your data, and you don't need to configure anything on the binary level, which you're going to look. In short, you're going to see how we set that up. It's not complicated. It's a kind of lengthy process. Okay, we're going to understand the inners, the inners of how Apache Kafka works, and it's kind of a lengthy process. Apache Kafka seemed like a very good choice for replicating data. It's mainly used for streaming, but we can use that as a data replication solution as well. Cool. So if we put Apache Kafka in the location where we had replication, we're not going to have a publisher anymore, but we're going to have a producer, a data producer, if you say. We're not going to have articles anymore, we're going to have topics. And we're not going to have a subscriber anymore, we're going to have consumer. And also, we're not going to have a distributor anymore, we're going to have the Apache Kafka binaries running here to orchestrate everything that we're doing, which is what we want to achieve, right? We want to get data out of the producer and push that data into our consumer. And I can do that, for example, between two SQL Server instances. Pretty straightforward. I'm not going to do that if I already have the native replication from SQL Server, right? But I can do that for example, from a Postgres instance into a SQL Server instance. That's pretty much what we're doing right now and what we're doing in this session, okay? I can also do, for example, a Postgres instance as as our producer and a MySQL instance as a consumer. Anyway, it's a pretty much pick your tool of choice, right? So our first solution is to use Kafka manually, meaning we create the cluster, we create the VM, we pretty much create everything that we need in order for the whole solution to work, right? That's how we do it manually. And there's another solution, which is using a cloud-based service, which is the Apache, the Confluent IO solution, right? But let's talk about the first solution, which is using that manual approach, which is good for understanding, right? So we're going to define a data source or producer, and we're going to define a destination or consumer. Again, I'm using singular here, but I could be using plural, okay? I could be using data sources and I could be using data destinations, but I'm using only one to keep things simple, right? Okay, you're going to install the Confluent Kafka platform. So you're going to install a whole set of binaries in the server that you're deploying it, and bear in mind that this is designed to be used in clusters. This is designed to be fault tolerant. This is designed to be highly available. Okay, we're going to use only one VM in order to have an idea of how it works, but it normally works cluster based. Okay, it normally works based on several compute engines, not only one, right? We're going to install all the required drivers, because each connector, each source and destination normally requires a driver. It's going to be very rare that you're going to install the Confluent Kafka platform and it's gonna have all the drivers that you need. No, you're probably going to need to download the drivers and then install them properly. Okay, we're also going to create the connectors using the drivers, and I'm gonna get there. Okay, then we're going to monitor the data going back and forth, like we saw that earlier, right? I pretty much started the session with showing you guys how that works. Then you sit back and relax. It's not that easy, that simple, but I'm gonna show you that it's highly doable, okay? And it's a pretty darn good robust solution for any sort of heterogeneous replication that you might need to set up on your environment. Okay, so without further ado, let's see how we set this up in Linux. Okay guys, so let me tell you what I have here right now in this VM. At this point, at this session, I have the Red Hat installed. It's a Red Hat 8.5. It's free to download, but you need to create a subscription in the Red Hat portal. Links to everything that I'm doing here are in the GitHub that I showed you guys earlier. Okay, all right. So I have a Red Hat installed and I have a Postgres installed as well. I choose Yum as my package manager. It's easier to handle packages, almost like Windows Update. Anyway, at this point, I have Red Hat and I also have our Postgres instance properly configured. What do I mean by properly configured? If you simply install a Postgres in your Red Hat VM, for example, you're not going to be able to extract data from it directly, or at least using Apache Kafka natively. You're gonna need one extra driver, which is called the Basium. The Basium is the driver that's going to do the midfield between your Postgres your Postgres logical replication engine and Kafka. Okay, that's what's going to enable Kafka the usage for reading data from Postgres. Okay, that's the first portion of it. All right. Okay. So we have Postgres already configured and already with some data. If we look at that, for example, I showed you guys already, but if we select star from person, for example, you're going to see that we have data, right? Oh, by the way, in our SQL Server, I removed the table, okay? On purpose, I dropped the table. So you're not going to find the person table here anymore because I simply dropped it so we can repopulate that again, right? Repopulate again, yes. All right, awesome. Okay, guys, so I do have Red Hat, Red Hat 8.5 installed, Red Hat 8.5 virtual machine installed. You're gonna need, in order to install Red Hat virtual machine, you're gonna need to create a subscription in the Red Hat portal. It's free. You can download for development purposes. It's free. You can download as many as you like, and you're gonna need to sign up for your VM. You're gonna need to register it in the Red Hat portal. They probably want to use some telemetry data or anything of the sort. It's running right here. It's that Jupyter whatever instance. It currently has 12 gigabytes. It's using only 4, but I assigned 12 gigabytes for that, and also 4 CPUs. Okay, it's a Hyper-V VM, pretty straightforward as well. And what do we have here in that VM? Only the Postgres. We only have the Postgres instance. It's already installed. It's already configured open for remote connections properly, and also the replication setup that we need is already there. It's using logical replication, and it's using the native Postgres logical replication. So after we install the Confluent platform, we're gonna need to install a driver called the Basium. That driver is going to work with the Postgres replication engine, so Kafka can read from the Postgres. Okay, so that's the very first driver that we're gonna need to install after we install the Confluent platform. Let's see. We're also going to need, in order for the Confluent platform to work, we're also going to need to install Java. Yes, Apache Kafka is Java based. And if we don't have Java, it's not going to work. Not everything is perfect, right? Joking? I'm kidding. All right. So as a first startup or kickoff process, we have that Confluent. Again, remember I told you about Confluent.io. Confluent is the company that was created by the team of engineers that created Apache Kafka, that created Kafka, and then later open sourced it into the Apache Foundation, and then later founded the company. And speaking in a very simplistic way, they serve Apache Kafka as a service in any cloud provider that you like. Any of the 3 largest ones, right? Any of the 3 most relevant ones. Google Cloud, Microsoft Azure, which is the best because it's Microsoft, and also AWS. Okay. All right. So prerequisites. You're gonna need to. You can either use Docker, but I prefer using the entire VM stack or the entire VM roadmap because it's easier to see how it works underneath. Okay, and we also have tar archive, which is pretty much what we're going to do right now. We're going to download the tar archive, and then we're going to put that archive or that file inside our file system, and then we're going to decompress that file, and then we're going to go from there. Okay, after we have installed the Confluent platform client, we're going to install the 2 drivers that we need, the Basium for the Postgres, and then right afterwards we're going to install the sync driver for SQL Server, which is pretty much a generic JDBC driver. Okay, and then we're going to create the connectors. All right. Also, all the links that you guys need to recreate this scenario are in the GitHub that I sent, that I added the link earlier, right? So let's see. Let me remove that. Right, so I have this file, Confluent 7.2.0 tar.gz, and I need to put that in here, in that VM, right? How do I do that? If I'm using MOBA Xterm, which is that application, I can simply click here. The left-hand side shows me the file system, the entire file system, whereas the right-hand side shows me, well, the bash for inputting commands and things like that. Okay, OPT, stage, but I already have that downloaded here because it takes a while. But if you simply drag that here, it's going to copy that over for you, okay? I'm not going to do that because I already have it here, right? So let me expand that a little bit, okay? Remove that. If I hit LL here to list my file system, I am currently in /opt/stage, and I have the file that I need right here, okay, Confluent 720. Right. So what now, Marcelo? We need to extract the contents of that file. So tar -xvf, right click, enter. Wait a bit. It takes a while for that to fully uncompress. It's going to take a while. Okay, so let's wait a bit. All right, fantastic work. It already decompressed everything. Awesome. So if we list, we're going to see that it created a new folder for us right here. Okay, I'm going to go ahead and move that folder. Move Confluent 7 to one level up. Right, it's gonna go to /opt. It's not going to be in stage. Okay, so let me go there. LL, okay, Confluent 7.2.0. All right, awesome, fantastic. And if I go into Confluent, I'm gonna see that all the binaries that we need are in the bin folder. Of course, we have Confluent and we have Confluent Hub, pretty much everything that we need. If I execute Confluent, you're gonna see that, well, it's pretty much running. Awesome, fantastic. But I need that to run from any point of the operating system where I am. So I'm gonna have to create a session variable, and also I'm gonna have to put that variable into my bash profile. And for you, sysadmin that works with Linux, yes, I am going to create a bash profile. I am going to edit a bash profile for the root user. Yes, you can judge me all you want. This is only a lab, and I'm doing that for the root user. You're gonna have nightmares today. All right, so in order for that to work properly, we're gonna need to export Confluent home. Confluent home equals opt. Yes, I'm using a cheat sheet here. Confluent home opt. All right, awesome. Let's see if that works. Home. All right, it works. It gets me to the right. It gets to the right folder. Yes, it gets me to the right folder. Awesome, fantastic. And also, I need for that to be, if I click here, you're going to see that if I try to invoke the Confluent command, the Confluent client, it doesn't work because it's not in the path variable. So I need to push that into the path variable as well. So I export path. It's the same as set in Windows, pretty much the same. Equals the very same variable. We don't want to remove everything that we had. We also want Confluent home, but we want the bin folder from that. All right. So now we have, if we echo that variable, you're gonna see that you have Confluent bin there. All right, fantastic. So if I now execute Confluent, you're gonna see that the client works properly. Awesome, Marcelo, fantastic. And now, how do we make, or how do we see if Kafka, if the Kafka service stack is running or not? Well, you can use Confluent services status to see all the stack of services, local services that are running. Everything is pretty much down right now. If I hit start, it's obviously not gonna work because, like I told you guys, this is Java based and there is no Java installed here. Okay, so I need to install Java as well. If you have, depending on the internet speeds that you have, you might get this done real quickly. So Java install, yum install Java. That's it. Simply put, very easy, very straightforward. It's going to install the runtime environment that I need right now. Okay, might take a while as well. Hit OK, and that's it. Okay. Now we do have a Java runtime. Good. Marcelo, you also mentioned that firewalls should be off, right? Yes, exactly. Systemctl firewall status, firewall D. There's no, it's disabled, okay? So the service for the firewall is pretty much disabled. Again, don't do that in production, right? Keep things fairly safe in production. Don't do that in production. It's also open for, it also has a network address translation here in my VM. Don't do that in production. This server doesn't need direct access to the internet as well. Okay, it only needs access to the Confluent repositories, and that's pretty much it. All right. So now, if I invoke Confluent local services start, I'm gonna see that well, it pretty much tries to start, right? It's using a temporary folder here, and it randomly creates the number, and all the data that we're going to generate is gonna be stored here in that location. Marcelo, can I read that data plain text? Nope, you cannot. For security reasons, you won't be able to read it, well, obviously, right? Otherwise it would be very easy to tamper with data in transit. So no, you cannot read that data per se. You can see that data is flowing, coming and going, pretty much going into the messages, etc. But you really cannot, and you should not use that. Marcelo, is there a way to see the logs? Yes, if you're a kind of somehow geek like me, yes, you can see the logs as well. Sometimes it fails to start, and you simply hit start again, and it goes up. It's like that. Anyway, I can connect here in another session into the very same VM. Okay, so let me increase the size here, Confluent, and we get to a problem here. Command not found. Confluent command not found. We need to add that to our bash profile then. So every time that we connect, we have all the variables already set up properly. So let's do that let's do that right now. I'm already in home, in the root home. Okay, if I select and I use that symbol till, then I get to home. And if I use vim.bash profile, you're gonna see the bash profile file here, of course. And then I hit I, which is the insert mode. Then instead of exporting path, I'm also going to export Confluent home as, I'm going to copy that over here, avoiding mistakes. Okay, yes, and then I'm going to export path equals path plus I want Confluent home \bin. Okay, ask to go out of insert mode, then 2 dots WQ in order to quit and write or save the file that I'm using here. Now if I hit source, then the actual file \bash profile, it's going to now evaluate and reload the bash profile file that I just edited. And now if I hit Confluent, it's gonna work. This is the second window that I have for that session. Okay, I have another one right here. It's already up, everything is already up and running. Okay, awesome, fantastic. So now in that case, I already have pretty much all the Kafka stack, all the Kafka services stack open, up and running, and ready to receive, ready to pretty much connect to my data sources. But I'm gonna show you guys that it's not possible just yet to connect to them because we don't have the drivers, right? Plugin list. You're gonna see that I don't have a Debezium connector here, and I don't have a JDBC sync connector here. You see that Apache Kafka or the Confluent platform only comes with these four native drivers, which is pretty straightforward for them, but it doesn't serve us any good. We need to install 2 more drivers here, all right? And it's also a very straightforward download, or very straightforward execution, right? I'm gonna use Confluent Hub install, which is another client as well. Okay, then Confluent Hub install, and I'm gonna copy paste that. Sorry guys, Debezium, the latest version that you have for Debezium. Okay, yep, go for Confluent Home. Yes, you pretty much accept. It's a next finish scheme. All right, yes, that's it. Yes, all right, awesome, fantastic. Now I'm gonna go ahead and install the JDBC driver as well. Okay, latest, pretty much the same thing, pretty much the same. You're gonna see that it's the same command. It just I'm just switching the Kafka Connect JDBC. I'm just switching the name here, but it's pretty much the same. Yep, install, yes, takes a while. Yes, I accept. All right, pretty straightforward. It's going to also add everything that we installed to the proper property files. All right. So if we and now we are ready to list all those plugins. However, you're going to see that it's like changing a big and important database parameter. We need to stop and start the service, and the Apache service that needs to be stopped and started here is connect. Connect is pretty much the service that does all the magic, that performs all the magic that we need here. Okay, so I'm gonna go ahead and stop the connect service, which is Confluent local services connect stop. Okay, it's gonna stop. Then I'm gonna go ahead and local services status. I'm gonna check all the status. Local services start. Then it's gonna try and start the connect service. Just wait for that to start, for the connect to start. It takes a while, and then we can go from there. Okay guys, so if we look at the services, Confluent local services status, we're gonna see that pretty much everything, the entire stack for Kafka is up and running. And if we check the plugins for Connect, you're gonna see that a couple of other Connect drivers were added. First things first, this is one of the plugins that we need, and also this one is another one of them. So this is going to be used for Postgres or for producer, okay? And this is going to be the one used for our consumer, all right? This is a sync, and this is a source type driver, okay? Whenever we have a writing driver, a driver that's gonna push data, we call it sync in the big data world, okay? So awesome, fantastic. Now we have the plugins, now we have the drivers, now we pretty much need to create the connectors. You have the connect service, and then you have the connect the connectors themselves, okay, which is the portion of Kafka, of the Apache Kafka stack, that's actually going to connect to the services that we're looking to replicate in this case. All right, so I'm gonna go ahead and show you guys what it looks like, how to create a service like that, a connector like that. So we are at home, OPT stage. You're gonna see here two files, two JSON files, okay? One of them obviously is the one that I'm going to use to sync data or to push data into the SQL server. And the other one is the one that I'm going to use to create the connector from the Bezium or from Postgres, okay? Which is the second one. So if I hit CAT and the name of the file, it's going to list me the entire contents of the file. And it's also not so straightforward. This requires some sort of research, but it's pretty much ready to go here. So we have the name of the connector that we're creating right now. We have the class for the driver that we're using. We have the host name. In this case, it's Postgres the Bezium, right? And we have the host name, which is localhost. We have the name of the plugin that's going to be used in order for the Kafka to understand, or for the Bezium to understand the Postgres replication, which is PG output, which is the native logical replication for Postgres. Then we have a publication name, database port, password, everything that we're already familiar with, okay? And we have some transforms rules here that are actually needed as well. So the Postgres, the Bezium JSON has these lines. So let's create the actual connector for that JSON, for that the Bezium driver. Right, I already have that not created, but I already have the command here, which is grep curl, which is one of those. Okay, I'm gonna go ahead and simply copy paste it, and I'm going to tell you what I'm doing right now. So whenever Apache Kafka is up and running, it's pretty much a REST service, and I can use curl to interact with that, okay? Creating connectors, removing connectors, checking, looking into messages that are arriving, looking at messages that are going, things like that, okay? So if I go ahead and create post, I'm gonna go ahead and use the Bezium.json, Postgres the Bezium.json. Let me adjust that, okay? Now we're good. Okay, so it created the connector for us. Okay, the name of the creator is the connector that it created is Postgres Debezium, but it doesn't show us any status. It simply says that, oh, I successfully created it. Right, let's pipe grab it again, and let's see if I can see the, you can see the command here, right? Right here. Right here, okay, 182. If I simply 182 here, exclamation mark 182, it's going to execute the command for us, the command in history for us, and it says that it's running. Okay, good, fantastic, awesome news. So our connector that goes to the source data is running. Let's see the log, because I don't 100% believe it. So Confluent local services connect log. It captures the LSNs that we need. It found a schema. Good. It found a table, public person. Awesome. It's not going to show you the data itself. It's going to show you the amount of records that are gonna be exported, but it's not gonna show you the data itself, okay? For security reason, it's not for security reasons. It's not gonna show you plain text the data that is there. All right, fantastic. So we have that data there. Awesome. Am I able to check in the Kafka topics, within the Kafka topics, if the messages are already there or no, not at all? Yes, of course we do. So first things first, let's show all the topics that this Kafka is running. It's going to list all the Kafka topics. Articles, remember, replication, articles, yes. All right, all the ones that you're looking here, from here upwards, are system-based. We only need this one, so Jupyter 2 public person is the one topic that I'm interested on. And how do I see the messages? You're gonna see that Kafka is pretty much going to show us. It doesn't show much, but there's something. You can see that there's something in the output. And if I Control C that, you're gonna see it processed a total of 8 messages. I've seen that number before. 8 messages, 8 lines of data, right? Again, now going back to our SQL Server, we still don't have a table created here because we didn't create we didn't create the sync connector yet. We only installed the driver, and we only created the source connector, the producer connector. Okay, awesome. So now we can look at the sync connector, which is the JDBC. Okay, so we are now using the JDBC sync connector here, type of class, name, pretty much everything. Where are you connecting to? My local laptop, database name, user, password, pretty much everything, and all kinds of transformations that are required for that data to be properly added into the table or into the tables that I'm looking for. One quick note here, Kafka here is going to create one topic per table. Okay, this is how it's configured. This is how the Debezium is configured by default, and this is how we recommend you keep it, right? So I subscribe or I consume topics or tables. Okay, if I had one extra table here, I would simply add a comma here and add the entire name of the table here to the side as well, okay? So that it could understand the amount or the number of tables that it needed. You can also use regular expressions here to create a list of tables. But since we have as of right now, only one table. I'm simply adding the name here. And if we had up to, I don't know, 5 tables being consumed, I would simply add the names there. Pretty straightforward, right? So I'm gonna go ahead and create this connector as well. So history grep curl. And over here, we can create a connector based. Over here, we can create a connector based on, guess what? SQL Server JDBC. Okay. Hit enter. It creates the connector. Awesome. How do we see the status of that connector? 444, right? 444. Okay, it's running. Awesome. Fantastic. And if we go to the log, Confluent, local services connect log, it's going to show you that your JDBC writer is connected and it found the table. Interesting. And it also needs to create the table dbo.person. Awesome, fantastic. So it creates the table and it pushes data in there. If we come to the SQL Server, we can refresh tables and you're gonna see that now you have a DBO person table. If we select star that table, you're gonna find, surprise, surprise, the data that you used to have here. Okay, remember? So in short, what did we do here? We pretty much defined our data source producer and we defined our consumer or data destination. We installed the Kafka platform, we installed the required drivers, we created the connectors that needed to be used with the drivers that we had installed in the previous step. We checked data flow from the logs. You could see the data flow, right? And pretty much sit back and relax. Okay, so in essence, that's pretty much what we did, and that's pretty much how it works, right? You can use Apache Kafka to virtually replicate data from literally any data source into any data source, really and literally, right? So another solution would be to use the Confluent Cloud. The Confluent Cloud is an offering, or it's a marketplace product that is in Azure, in Google Cloud, and also in AWS. Is it good or is it bad? Well, it depends. It depends on your opinion. I find it awesome because it cuts you a lot of steps and you simply pay on a per use basis, pretty much. Okay, and you choose where your data is: Azure, Google Cloud, or AWS. Right? So we basically have two main solutions for replicating data in different technologies. Whenever we have an heterogeneous scenario, we can use two main solutions. We can either use Apache Kafka to set everything up manually, which is very time consuming and very lengthy process, but it's good to do it once to see how things operate from an under the hood perspective. And there's simple plug and play usage, which is using Confluent, the Confluent Cloud, which is pretty straightforward. And with that, I thank you guys very much for attending this session. I give a special thanks to Microsoft for supporting our awesome Data Platform Summit. We also have prizes, so post your selfie with the hashtag. Please give us feedbacks, help us improve. Also visit our sponsors and exhibitors. Also follow us on Twitter. I hope you enjoy the rest of the summit sessions, and I also hope that you can replicate as much data as possible. That's it. I'm here for questions if you have any. Cheers, guys. Thank you.